Hello, AP Environmental Scientist. This is Miss Maycutt from Ballard High School, and I'm going to go over your personal progress check number 3. This is just a reminder, the EK is about focusing primarily on non-renewable energy. So, go. The main concepts that we focused on was distinguishing between the properties of non-renewable versus renewable energy sources, plus the extraction, processing, and use of some of these fossil fuels, their sources. And then, of course, graphs and data interpretation. That actually tricked up quite a few people. Common errors were reading the questions for what they're asking and being careful deciphering the graphs and tables. So we're going to focus on questions numbers 2, 5, and 6 first, and then we'll go over the rest of them. So question number 2, which of the following best describes the total consumption of all fossil fuels in 2040 compared to nuclear energy? Well, question A is correct, but why? So let's look at the why. It's looking at all fossil fuels. Okay, so all the fossil fuels, what are those? And this is in compared to nuclear energy. So let's find them. So here we have liquid gas, there's natural gas, and there's coal. So you had to add those 3 together, and you had to read the graph carefully, and you had to not mistake the funny little dot dash dot versus the dash dash, right? Easy mistakes. The nuclear energy was down here. So we take a look, that would be 250, 180, 215 approximately. Gives you approximately 245 BTUs compared to nuclear at 48. So that was what we were looking at for, and why question number A was correct, because that's approximately 13 times as much for the other ones. In B, it was incorrect because it failed to include coal. C was incorrect, failed to include natural gas and coal. And D, compares fossil fuels to renewable. So looking at the wrong things. Okay, next question. After the Industrial Revolution, the use of fossil fuels increased significantly. All right, even though this is environmentally bad, why is it we continue? Why do we continue to stay with these non-renewable resources? Which statement best explains why? Okay, so focusing again on the why is there continued widespread use of non-renewable fossil fuels? Question A is actually correct. The systems are already in place to transport and deliver fossil fuels. Now, you probably figured that out, but it might have been an issue of looking at some of the other questions. Significantly, fossil fuels are cheaper than renewable. We hear that again and again and again. But what's actually cheaper? You're telling me coal and oil are cheaper than wind and sunlight? No. So they're technically not cheaper, and fossil fuels and the whole processing of fossil fuels is heavily subsidized by the government. Environmental effects of fossil fuels, easy to mitigate. Incorrect. This is a mess and it's costing us tons of money. They'll always be present. Fossil fuels, heck to the no. That's part of the big problem. Okay, so moving on to our next one. Whee, put in the star, and here we are. How much greater is the average cost of electricity produced in the US from offshore wind than from hydroelectric power? Okay, for this one, again, we have to focus on its offshore, and we're looking at wind and hydroelectric. This was really the biggest problem, folks. We're just not looking at the right part of the graph, right? So you had to get the averages, that's down there. So were you actually looking at this number and this one versus some of the other ones? So here we have C is correct because we grabbed that 197, right, from offshore wind farms versus the 84 hydroelectric. Divide 197 by 84. That gives me 2.3. Okay. A is incorrect. Go back. A is incorrect because it's reverse the values. So you might have flipped them, right? But remember, it's asking the average cost for telling which one goes on top, right? So it's asking how much greater is the electricity from wind than hydroelectric. So if you're looking at greater, you know that the larger number has to go on top, right? So that was an easy mistake. Some folks went to the A for that. Some folks of you, like I said, looked at onshore wind, or you didn't look at the averages. And that's a whoops. Okay, now we're going to go over the rest of the questions a little bit more quickly in a little less detail. So number 1, what was the approximate projected rate of change in renewable energy? Okay, So again, it's a rate of change. It's renewable. Look at the right spots on the graph. So you have to have point A to point B, and you're going to get their difference. So that's 130 BTUs minus 60 BTUs divided by time, right? So the change in the value divided by time, that gives us 2.3 quadrillion BTUs. And the next one, which of the following best describes difference between non-renewable and renewable energy sources? Remember, we skipped 2 because we already went over it. So non-renewable energies release carbon dioxide when used, whereas renewable energies do not release carbon dioxide. This is a big one people make a mistake on. Geothermal, biofuel, and hydropower all release carbon dioxide. Yep, bet you didn't know that. Okay, you should have because you watched the videos and you did your homework, but maybe you didn't. B, produces energy that can be recycled. Can we recycle light and wind or the heat released from geothermal? Not really, no. And can they be replaced naturally at current consumption rates? Yes, they're all very replicable. That's why they're renewable by definition. And most renewables are locally sourced generated. The argument was they're from a long ways away. Typically not. Okay, next one, number 4, which best identifies a benefit of using renewable energy sources rather than non-renewable. A is correct because it is replenishable and inexhaustible. We have unlimited sources of these forms of energy. We can grow more plants, we have abundant wind, light, and the heat from the earth will not go away. Then renewable energy sources don't have negative environmental effects. All forms of energy have some effects. The infrastructure, the transport, the technology, right? They all have certain effects. So we can't say that they have no environmental effect. Are available uniformly. They're unequally distributed, right? They're going to get a lot more sunlight in Africa than they are in the Arctic. And technologies are more developed for renewable. Heck to the no, I wish. That's part of the big problem is we keep putting government funding into non-renewables because they have bigger lobbies. Okay, natural gas, a non-renewable fossil fuel seen as an alternative to the worldwide transition of a renewable energy force. What of the following statements best explains why it's used as a fuel when countries are transitioning from non-renewable to renewable? Well, natural gas can be used in industrial applications only. Heck no. It's used for all sorts of great stuff. So power, heat, homes, transport. So that's not right. Process of extracting natural gas, as known as hydraulic fracturing, requires little water. Well, of course it requires water. It requires a lot of water. It's hydraulic fracturing. So no. Infrastructure of storing and transporting gas can be used in conjunction with hydrogen fuel technologies. Other fossil fuels are easy to transport. This is like a tangent question. And then natural gas burns more efficiently and cleanly than other sources of carbon-based fossil fuels. So it does not release quite as much CO2 or the heavy metals of coal and petroleum. It does release more methane than some, which is problematic. But among our answers, that is the reason why. Which of the following is an example of the process cogeneration? Okay, I know a ton of you are like, what the fork is cogeneration? Co, break the word down. Generation, co, and generating something. Co-generating. Okay, it's two things combined. Co, together, generation. Well, this is about energy. Cogeneration, so energy. And then let's break them down. Timber for biofuel. Timber is not energy. Okay. Wastewater from electricity to heat homes. Electricity is a form of energy. Heat from the wastewater is a form of energy. So that one is actually correct. Reservoirs behind hydraulic dams for recreation. Recreation is not energy. And corn crops for ethanol. Food is not energy, except for us, right? Which of the following describes why people in less developed countries use wood as a primary energy source? Can be converted to peat? No, that's hard. No. Lots of pressure and time. Infrastructure for transport. A lot of these places, their feet are their transport. There isn't an infrastructure per se. So that word itself is just a distractor, right? Wood in the form of firewood and charcoal is readily available. Okay, pretty much every place where people live, there are plants. And if there's plants, there's going to be something you can burn. And the wood produces fewer carbon emissions. It's one of the stinkiest, messiest ones out there. So no, it's a real problem. Okay, question number 10 is a little tricky because this one had an error. You'll see right here it said export, and this is looking at the reliance on foreign sources use versus import. So US here, we're importing 4%. And the way you can figure that out is Saudi Arabia, right? We know they're exporting in abundance. So that negative value has to be an export factor. So looking at this, the US, United States produces more than it consumes. Heck no, we depend on 14% import, right? Russia with Indonesia are reliant on export of other nations. No, both of them are exporting. They have negative values, just like Saudi Arabia. Saudi Arabia and Austria, large volumes of fossil fuels with low energy, they produce a lot. They're both exporting. And Japan, it's actually at 94% import. So it is the most dependent for its fossil fuels acquisition. Number 11, last one, we're talking about the formation and destruction of rock is known as the rock cycle. And if a country has a lot of fossil fuels or oil and gas reserves, what kind of rock type has to be underlying the geology of the country? Okay, and here's the key question. So oil and natural gas are fossil fuels. So all fossils are found in what kind of rock? It's always sedimentary. It has to be sedimentary. It's mandatory it's sedimentary, right? You can get coal from a pretty slow process of just sedimentation. You don't need a ton of metamorphosis to get that. So we're by far looking at sedimentary rock to get the acquisition of fossil fuels. So that's a wrap. I hope this was helpful. Good luck, everyone, and have a great day.